Welcome back, everybody. This is a continuation of my previous video of standard form of a quadratic function in vertex and axis of symmetry. We're given a function here, 2x squared plus 8x plus 7, and we're asked to identify the vertex and axis of symmetry. So let's go ahead and do this. Now, before we begin, we want to make sure that the leading coefficient is 1 instead of 2. So what we're going to do is we're going to factor the 2 outside, and then we're going to perform the perfect square method. And if you're not familiar with this method, you can check out one of my videos that I've posted on my channel. But just to save time, we're not going to go over it. So beginning with this problem, we're just going to factor the 2 outside, and then we're left with x squared plus 4x, and then I'm going to leave some space here, and then I have the plus 7 hanging outside here. Now, according to the method, what we do is we take 4 divided by 2 and then square the whole thing. So 4 divided by 2 is 2, and then 2 squared is positive 4. So we're going to add 4 here. Then we're going to subtract 4 and add the 7. I'm just going to go ahead and erase this. Now, since we performed this method, let's not forget that we have a 2 hanging outside here, and because we do, it's going to, we're going to have to multiply 2 by negative 4, but we're not going to touch the 7. So eventually our function is going to turn out like this: 2 times x squared plus 4x plus 4 minus 2 times 4 plus 7. Now we can further simplify this. We're gonna get 2 times x squared plus 4x plus 4 minus 8 plus 7. Because eventually we're trying to achieve the standard form of a quadratic function. And as a reminder, we're trying to keep the leading coefficient here 1 to make things simpler. So 2 times, or we can go ahead and factor this actually. We got to think of 2 numbers that if you multiply, you'll get 4. And if you add together, you're going to get positive 4. So the one number I can think of is positive 2. So, excuse me, we'll just go ahead and do this. Then we have negative 8 plus 7. Negative 8 plus 7 is just going to give us negative 1. And that way we have achieved the standard form of a quadratic equation. We have our a outside, we have our vertex, which is here. Then we have, we have both points of the vertex, which is negative 2 here. Remember to flip the sign. And then we have negative 1 hanging outside here. And as you can see, just by looking at this function, we can tell that the graph belongs to the parent function 2x squared. And the graph has shifted 2 units to the left and had a vertical shift of 1 unit down, which is what this negative 1 represents. So we can go ahead and just by looking at the function, determine what the vertex is going to be. But I'm going to write this in green just to color code it. So vertex v is equal to negative 2. Remember to flip the sign, and negative 1. And I'm just gonna go ahead and label this here on the graph, -2 and -1. So the graph is going to be somewhere here. And since there's no negative in front of the function, we can tell that the graph is positive, and then it's going to be pointing upwards. And then we're asked to identify the axis of symmetry, but before we do that, let's go ahead and try to graph the function. What we can do is we can plot or construct a table of values. Since we haven't done that in the previous video, I'm just gonna go ahead and do it right now. Let me move the camera just a little bit to the right. Okay. Now, when we construct our table of values, you want to pick values, you want to center the vertex somewhere in the middle and choose points that are before it and after it. So we have x here, and then we have f of x. Since at -2, we're going to get -1, which is our vertex. Let's choose values smaller than -2. For instance, let's say -4 or -3. Let's choose -3. So putting -3 here, and then -4. Let's choose -3 here, and then -4, and then from -2, get -1, and then 0. So all we got to do is just take those values and plug it into the original equation. Excuse me, we plug it in here. So taking -4, we're going to take 2 times -4 plus 2, which is simply, -4 plus 2, which is simply -2, and then squared minus 1. -2 squared is going to give us 4. 4 times 2 is going to give us 8. And then 8 minus 1 is going to give us 7. We have -3. Well, -3 plus 2 is going to give us -3 plus 2 is going to give us -1. And then -1 squared is going to give us +1. +1 times 2 is 2. And then 2 minus 1 is 1. Now we already have our value here, which is the vertex. I'm just going to put a star next to it. And then we have a -1. Oh, excuse me. I made a mistake here. That shouldn't have happened. Taking -3 into the function. Well, I did the same thing up here as well. So as long as our math checks out, we're fine. So we said 1 squared times 2 is 2. 2 minus 1 is just 1. And then -1 here. -1 plus 2 is going to give us +1. +1 squared times 2 is 2, and then 2 minus 1 is going to give us 1. And then plugging in 0, 2 times 0 plus 2 is 2. 2 squared is 4. 4 times 2 is 8. 8 minus 1 is going to give us 7. Now let's go ahead and plot those points. So we have -4. At -4 we have 7. -4 we have 7. we can stretch our graph up here. Say here we have 1, 3, 4, 5, 6, and 7. So 7's right there. So at -4 we have 7, -4 and 7. So the point is somewhere here. Then we have -3 and 1, which is here. We already have our vertex. Then we have -1 at 1. -1 at 1. Then we have 0 at 7, which is just straight up on the y-axis. Then if we go ahead and plot those points, we're gonna get our curve. It's gonna look something like this. Sorry again, it's a little bit sloppy, but you can see what I'm doing here. Of course, this is gonna go on forever. And there we have our positive parabola. The axis of symmetry occurs right through the vertex, and then the vertex is just at x equals -2, which is right here. Remember our formula for to find the x coordinate of the vertex. X is equal to -b over 2a. And if we were to apply this formula, we have to look at our original equation. We have -b, which is 8, over 2 times a. A is just 2. So -8 over 4 is -2, which is exactly what we have here. So that's it for this example. You can look at the other example I did in my previous video. It's the same exact thing. However, the difference is we used finding the x-intercept method instead of plugging or constructing a table of values right here. Both methods will work just fine. Again, as long as your algebra is correct and as long as you stay consistent with your math, everything should check out fine. Now please don't forget to like this video and subscribe. This is going to help grow the channel more. If you have any questions or concerns, please leave a comment in the comment section below and I'll make sure to get to it. So thanks for watching again, and we'll see you in the next video.